We are now recording. Okay, so we are going to talk about exponential growth today. Exponential growth can be modeled with the following function. We kind of talked about this yesterday. The basic form of this function is y equals a times b to the x power. Okay, it's this right here. And I put it down here with some space around it because I want us to label the a and b. We label the a and the b. The a is your starting value. Okay, remember the mouse problem yesterday? Yeah, we started with 2 mice in the barn. That 2 is your starting value. So that would be your starting value. Your B is your growth rate. We're going to learn how to find a growth rate today. Okay, so what we're going to do today is we're going to write equations that model exponential growth. So we're going to model some equations, write some equations. We're really going to be talking a lot about compound interest. Yes, Quincy.
That was on the homework last night, wasn't it?
Yes, it was.
I didn't know how to do it.
It's okay. All right. If you did it after this lesson, you would know how to do it.
Yeah.
So.
Yeah, it was on the homework. So.
All right, I understand that. Example 1, it says, suppose you deposit $1,000 in a fund that pays 7.2% interest compounded annually. Find the account balance after 5 years. So we're going to put this, first I want us to write the equation. First I want us to write an equation. And to do that, we have to have 2 parts of the equation. We have to have A, we have to have the A value, starting amount. B, we have to have B. Yeah, that was redundant. So A equals your starting amount, and B equals your growth rate. So A is your starting amount. What is that in this? $1,000. Growth rate, we don't know how to find yet, but I'm going to show you. To find growth rate. Well, it's 7.2% is the interest that compounds. Okay, that's your interest. So what you do, you need to change it. Before you can work with a percent, you have to change it to a decimal. So what is 7.2% in decimal form?
0.72.
No, 0.072. You have to move the decimal place 2 places. So our interest rate we're working with is 0.072. It's the same thing as taking 7.2 divided by 100. That'll get you the decimal if you've forgotten how to do that. You take 7.2 divided by 100. That will give you the decimal. And then what you have to do with that decimal is add 1 to it to get the growth rate. You always have to add 1 to it to get the growth rate.
So it's 1.072?
Exactly. The growth rate is 1.072. So that is going to be our B, is 1.072. And that's what we're going to plug into our equation for B. So the basic form of the equation is y equals A times B to the x power. So we're going to plug A and B in. So we have 1,000 in for A. So we have y equals 1,000 times 1.072 to the x power. Now, x is always going to represent some form of, or some value of time.
5 years.
So in this case, the time that has passed is 5 years. Now, we can only use 5 if the words in the problem say compounded annually. This example does. We're going to do one. The next example is compounded quarterly. We'll talk about that situation in a minute. But for right now, annually, we do 5. We plug 5 in for x because it's 5 years. So we're going to do that equation where we plug 5 in. We have y equals 1,000 times 1.072 to the 5th power. If you do this all in your calculator, you've got to put parentheses around 1.072 in order for it to calculate correctly. Okay? But you should be able to do this whole thing right in your calculator. So do 1,000 parentheses 1.072 close parenthesis.
1415.708784.
Okay, round to the nearest hundredth because we're talking money. So it's what?
71.
1,415.
Yeah,
0.71. That means after 5 years at compounding annually at a 7.2%, your account will go from $1,000 to $1,415.71. That's all you do on that. Okay, sample 2. We're going to take that same situation. It's still $1,000 that you're putting into the account. This time I want you to notice what it says this time is to suppose the account in example 1 paid interest compounded quarterly instead of annually. So here's what you have to do. What's different here is you have to figure your time differently, and you also have to figure your growth rate differently. Here's how you find growth rate in this situation. Now, on the board, I have written what quarterly, semi-annually, and monthly are. Quarterly means it compounds 4 times a year. Semi-annually is 2. And monthly is 12, because that's how many periods there are in each of these situations. So this one's compounded quarterly. So what that means is we divide that interest rate into 4. Okay, so what we do is we take the interest rate 0.072, because you always want to work with the decimal form of a version, or it's decimal version of a percent.
Wait.
So we take the growth rate 0.072, and since it's quarterly, we're going to divide by 4. Had it said annually, semi-annually, we would have divided by 2. If it said monthly, we would divide by 12. So we have to divide that interest rate up into how many periods there are in a year.
So when it's annually, do you add?
What do you mean?
Because up here you said compounded annually and you added one.
Well, we're going to do that soon too. There's one additional step. See, up here, we were doing the same thing. We were just dividing it by 1 because it's annually. So here we're dividing by 4 because it's quarterly, and then we'll still add 1 to that. So what do we get when we take 0.072 divided by 4 and then add 1?
0.018 and then add 1.
0.018 or 1.018?
Yeah.
So that is our growth rate. That's how you find the growth rate. So if it's quarterly, you divide by 4. If it is semi-annually, you divide by 2. If it's monthly, you divide by 12. And that gets you a new growth rate. So we're not going to use the same one from the above. Huh?
Sorry.
Okay. So that's what we're going to plug in for B. We're still going to have the same starting amount. It's 1,000 times 1.018, and then to the x power. But we need to figure out what we're plugging in for x.
5.
Let's think about this. It's not 5 this time, and the reason it's not, it is going to be 20, Wesley. You're exactly right. It's because each year is compounded quarterly.
Oh, yeah.
How many quarters are in 1 year?
4.
4, and if we're talking 5 years, it's going to be 20, right? So this x is going to be 20. So we're going to, in our calculators, put 1,000 times 1.018 to the 20th power. Make sure you put this in parentheses in the calculator. And let's see what the difference is if they compound annually or quarterly.
1,428.75.
Oh.
So 1,428.75. So that's how much money you would make if it compounded quarterly.
That's low.
It's higher than the compounded annually.
13.4.
Yeah, you get $13.04 more if you compound quarterly instead of annually.
That's true.
It's about monthly.
Well, you could figure that out. We're not going to, but you could figure that out.
I don't know how.
You put 12. Well, you would put if we were doing it monthly, what number would we plug in for x if we're doing it monthly? How many?
1. Wait, 12.
12 months in a year.
630.
60. You'd put 60. You'd put 60 in. It would be a little bit higher. You'd make more money that way. Okay, let's go to the back side. Example 3. All right. Since 1995,
This is true.
the daily cost of patient care in community hospitals in the United States has increased about 4% per year. So that 4% is what we're going to use for our growth rate. Courtney, turn around, please. That's what we're going to use for our growth rate is 4%. In 1995, such hospital costs were at an average of $968 per day. So what is the 968?
Per day. Like the increase.
No,
That's A.
So starting amount.
it's our starting amount. So in our equation, we're going to have y equals, our starting amount is 968 times our growth rate. To find our growth rate, it's 4%. What's 4% in,
0.04.
yeah, it's 0.04. We add 1 to that, so we get 1.04. So that's our growth rate.
I'll do it.
So 1.04 to the x power. Right now, all it's asking us to do for A is to write an equation, and that's all we have to do for letter A. This exponent's going to be an x all the time. Like this will always be x. You're only replacing A and B.
So like on the homework, will that be part of it? Like just writing out the equation.
It may, yeah. There are some. It'll have you write the equation first.
So you don't put anything for x?
No, not yet. That's what letter B is. B says use your equation to estimate the approximate cost per day in 2010. Let's think about that timeline. How many years has it been since the starting amount?
15.
From 1995 to 2010 is 15 years. Unfortunately, it's 15 years. So what we do is we plug 15 in. So it's y equals 968 times 1.04 to the 15th power. So let's plug that into our calculators and see what we get
Oh no.
for the cost of a hospital stay in 2010. Yes, Tyler.
171,743.31.
So that means in 2010, approximately the cost of staying in a hospital is $1,743.31.
Are you sure?
For how
one
many
day.
days? A day?
What about today?
For a day, yeah.
Oh, dang.
All of that just for it.
Well, for today, if we wanted 2012, what would we plug in?
17.
17.
Oh dang, that's like.
Each year goes up.
Now, whether this is accurate and up to date, I don't know.
Probably
It's
like
1,885.
What is it?
It's 1,800. Wait, yeah, 1,885.57.
Okay.
That's not right.
Okay.
That's a lot.
That sounds about right. Okay, so your homework is page 479. You're going to do 2 through 18 even.
Yeah,